Hey, welcome to E-Learning Day number 3. Name that tune. You got it. That's Snow by the Chili Peppers. So this lesson is going to be done a little bit differently than what I've done in the past for e-learning. I found this screencast app on Google, and I'm able to screencast 10 minutes of video. So I'm going to have to do this very quickly. So what I'm going to have you do is take out your notebook and your periodic table. I'll ask you to pause the video a few times throughout the notes and write some stuff down. Please do that at that time, and then I'll come back and I'll continue on. But I only get 10 minutes to make these videos, and I've already done this once, and I don't want to do it again. It took me too long last time, so I'm going to go a little faster. But welcome to my lair in the basement of the Steve household. I have all the essentials. Got a basketball hoop, basketball, brick. I have my little cat, little stuffed animal that makes me happy. Okay, and most importantly, whales. Yes, whales. Okay, we're good to go. So the goal for today is to learn about ionic bonding. So last time we were in class, we talked about chemical stability and that atoms were chemically stable when they had how many electrons in their outer shell? Yes, you should be shouting at your computer, 8 electrons in the outer shell makes them stable. So every atom is stable with 8 outer electrons. By the way, if you were not here Tuesday, please watch the previous video before you watch this one. It's going to be a lot easier. Okay, so the first thing we're going to talk about, and we'll go real fast through this, is an ion. I want you to pause the video, write down the definition for the term ion. Ready, set, go. Okay, so you have that ion term written down. An ion is an atom that has gained or lost an electron. So if an atom loses an electron, it becomes charged. If an atom gains an electron, it becomes charged. Elements in groups 1 and 17 tend to do this a lot. Because they're unstable by themselves, they like to lose electrons to become happy. To represent an ion, we use what's called a superscript. Opposite of a subscript, it's written above the chemical symbol. So like sodium with a plus, chlorine with a minus, that's an ion. That's how we represent ions. Okay. Another example would be like magnesium makes a 2+ ion, or a +2. So what type of ion would the following atom make? Well, which atom is this? This is protons 3. Check your periodic table. It is lithium. You got it. So lithium has 3 total electrons. It has 1 valence electron. It is not happy with 1. It wants to either lose that 1 to get to 2 there to have a full energy level, or it wants to gain 7. Obviously, it's going to lose 1 electron. So if it loses this electron, that means it becomes an ion and becomes a charged particle. Well, what kind of charge is it going to have? Because electrons are negatively charged, if lithium loses that electron, it becomes more positively charged. It had 3 negatives, 1, 2, 3, and it loses 1. If it loses 1 of the negatives, then it becomes more positive. So lithium is going to form a +1 ion, which means it's going to be attracted to everything that's negatively charged. Okay, so that's an ion. That's an important thing to know. So let's get into what happens with ions. Okay, when ions attract, a bond is formed. I want you to pause the video now, write down the first 2 bullets here. And ready, set, go. Okay, so you have that written down. So when ions attract, a bond is formed, and that bond is called an ionic bond. An ionic bond is formed that occurs following the transfer of electrons between atoms. Keyword transfer, underline that sucker. It's an important word, transfer. Okay, when electrons are transferred, it's an ionic bond. Usually this happens between a metal and a nonmetal. So pause the video, write these next 4 bullets down. Okay, you have those written down. Metals and nonmetals usually form ionic bonds. Metals, again, are on the left side of the periodic table. So all these over here. So you're going to see like sodium and chlorine. So a metal with a nonmetal. Nonmetals are over here. So one of these guys with one of these guys. Potassium and oxygen will make an ionic bond. Okay. Usually they make crystals, very strong solids, crystalline solids. So crystals, you know what crystals look like? Look like this. Ooh, pretty cool. Yes, amazing, awesome, cool crystals, sweet. That's the kind of bonds that's the kind of compounds that those bonds are going to form. They have high melting points. They're called crystals. So let's draw a couple of these. It says in your notes, show how these form ionic bonds. I'll do lithium and chlorine as an example, but I want you to pause the video right now, take out your periodic table and draw a Bohr model for lithium and a Bohr model for chlorine. All right, so you have those two drawn. Now, I have them drawn as well. Let's look at what happens. Lithium is not happy by itself, wants to get rid of that electron. Chlorine, not happy by itself. 1, 2, 3, 4, 5, 6, 7, not happy. It wants to gain an electron. So obviously lithium is going to give an electron here. So on my test, to get all of the points you need to get to show an ionic bond forming, these are the things you have to do. 1, you have to show that that electron has traveled over here, okay, by drawing an arrow. So you're going to draw an arrow that says, hey, that electron went from there to there. Cool. So you don't have to erase that electron. I don't want you to do that. I don't want you to redraw it over here, but I want you to draw the arrow. Make sure that they're all stable. So lithium has lost an electron. It has 2. It's happy. Chlorine has 1, 3, 4, 5, 6, 7, 8. It is happy. It's gained an electron. So do that. Then I want you to, above the Bohr models of each, I want you to write the chemical symbol for each of them. So lithium. And I want you to also put their charge because now they're ions. So lithium is now +1 charged. +1. Get back here. There we go. And chlorine, that's terrible, is -1 charged because it has gained an electron. And the last thing to do to finish this off is to write the chemical formula. It will be LiCl. Wow, my handwriting is brutal. Okay. And that's all you got to do. Show the arrow for the bond forming, show the ions +1, -1, and write the chemical formula. Okay, going back to notes. I'd like you to try to figure out how magnesium and fluorine form an ionic bond. It's going to be a little bit different than the first one. Draw magnesium, draw fluorine, figure out what each one wants to do to be stable, and see if you can make them stable with an ionic bond. So pause it, try to do it for a couple minutes, see if you can do it. All right, so at this point, you have the chemical bonds drawn, and maybe you got it right. Maybe you've had it figured out. Awesome, sweet. I don't know. No way for me to know because I'm here and you're there. Okay. Hey, shout out to Evan. Evan, you're my boy. All right. So magnesium has 2 valence, not happy, wants to get rid of those. Fluorine has 7 valence, not happy, wants to gain 1. So it wants to gain 1. This one wants to lose 2. Obviously, these 2 can't go there because fluorine doesn't want to. Magnesium only wants to get rid of both, but it can't get rid of both right now. Let's just get rid of one of its electrons to this fluorine because it makes this fluorine happy. Come on, come on, come on. There we go. So that fluorine is now yes, it's -1. Yes, it's -1. F -1. Okay, fluorine's -1. It is stable and happy. Magnesium's now +1, but it's not happy. Hopefully you figured out you wanted to draw another fluorine over here because this fluorine has 7 valence electrons, also wants to gain 1. And magnesium will give its electron, its last electron, to that fluorine and make that fluorine happy. Okay, so now this fluorine is also -1. So -1 and -1, and this magnesium has given up 2 electrons. It actually works better with bad handwriting. Oh, never mind, it does not. We're figuring this out. Stop laughing at me. So that's magnesium is +2. So now our chemical formula is MgF2. They're both happy. Magnesium has 8 valence electrons. Fluorine 8. Fluorine 8. They're all stable. They're all happy. This is how an ionic bond forms between magnesium and fluorine. Now you might ask, Mr. Steve, could I have put a different atom down here, not fluorine? You absolutely could have done that. It could have been chlorine, or it could have been bromine, any other ones that have 7. But the problem is I asked you to draw an ionic bond between magnesium and fluorine, and to do that you had to put fluorine here. So we're done with notes. I want you to go back into Schoology, and you have a couple example problems to go through on an assessment. So why don't you go ahead and do that. All right. Peace out. Cat.